Good afternoon, everyone. So, yeah, as Barbara said, I'm Giulia Alemanno. I work at DLR in Berlin, and I'm the Envision VenSpec instrument lead scientist and the coordinator of the VenSpec suite, which I will talk to you about. We'll talk about that more in the next slides. So, I will show you an overview of the Envision mission. Okay, first of all, if you see my next slide. Okay, my first slide is an acknowledgement slide. So these slides have been provided by ESA and NASA in the Envision Science Working Team. The Envision Mission Project Manager at ESA is Ann Packard, while the ESA Project Scientist and the SOWT Chair is Anna Gretz-Ström, and the Envision NASA Project Scientist and SOWT Co-Chair is Mitch Schulte. And also here in this slide, you have a list of the Envision Science Working Team members. But let's start with the mission overview and status. So Envision is a fifth medium class mission in the ESA Science program. It has been selected in June 2021, and it has been adopted in January 2024. It's an ESA-led mission in partnership with NASA, and the mission has completed its phase B1, and the spacecraft procurement for the implementation phase has been kicked off at the end of 2024. The main goal of the Envision mission is to try to understand why Venus evolved so differently from our planet. And to do so, Envision has three main scientific teams, which are history, activity, and climate. So we want to understand how the surface interior of Venus evolved, how geologically active is the planet today, and how the geological processes shape the atmosphere and the climate of the planet. This will enable also a better understanding of the conditions for habitability in our solar system and also beyond that. So Envision really aims at providing an holistic approach in the study of Venus from its inner core to the upper layer of its atmosphere. Here you have an overview of the payload of the Envision mission. There is a VenSAR, which is a Venus Synthetic Aperture Radar provided by NASA, a SRS, a subsurface radar sounder provided by Italy, a radio science experiment provided by France, and then you have a suite of three spectrometers, which is known as VenSpec suite, composed by VenSpec H provided by Belgium, VenSpec U provided by France, and VenSpec M provided by DLR in Berlin. So a little bit more in detail about each instrument. So VenSAR, as I mentioned before, is a synthetic aperture radar. The instrument's lead scientist is Scott Hansley from JPL NASA. And the main goal of the instrument is to obtain images of the Venus surface at a range of spatial resolution at 30 meter and 10 meter pixel spacing regionally over regions of interest on the Venus surface. The important goal is to search for surface changes by performing radar repeat imagery, and also to measure surface topography regionally using stereo radar imaging. And VenSAR will also provide surface polarimetric data in order to study the polarimetric reflection and emission properties of the Venus surface. Then the radio science experiment is led by Caroline Demoulin from the Nantes University. And the main goal is to study radio links between the spacecraft and Earth to determine the Venus gravity field and to constrain the internal structure of Venus, but also to monitor spatial and temporal variation of H2SO4 and liquid and vapor form to understand the sulfur cycle in the atmosphere of Venus, but also to study temperature, pressure, and density profiles. Then Envision will carry also a subsurface radar sounder. The instrument lead scientist Lorenzo Bruzzone from the University of Trento, and the SRS will sound the subsurface of Venus to retrieve information on surface roughness, composition, and permittivity. Will observe impact craters and their filling, buried craters, tessera plains, lava floors, and their edges. Then you have the VenSpec suite. The VenSpec suite, as I mentioned before, is a suite of 3 spectrometers with a joint science team. The idea is that one instrument, the data coming from one of the VenSpec channels will not give us the full picture. That's why we have this joint team. We join forces to get the best out of our data. And we start studying the Venus surface with VenSpec HAM. Then we go to the intermediate layer of the Venus atmosphere with VenSpec H, and to the top cloud thanks to VenSpec Q. So VenSpec HAM is a multispectral imager. It is provided by DLR. I'm the instrument lead scientist, and VenSpec HAM will observe Venus with 14 spectral bands. 6 of these bands are will cover the range between 0.86 and 1.18 micron, and will observe the surface of Venus in 5 spectral windows, where the radiation coming from the surface can be detected at the top of the atmosphere of Venus. Then VenSpec HAM has also 3 cloud bands, 2 water vapor bands, and 3 background bands to correct for stray light analysis. So what we will do with VenSpec HAM, we aim to map the surface mineralogy of Venus, to monitor the planet for volcanic activity, and to map near-surface water vapor and cloud optical variability. Then we have VenSpec H, which is a high-resolution spectrometer. The instrument lead scientist Severin Robert from the Bira Institute in Belgium. It's a nadir pointing near-infrared high-resolution spectrometer, which will provide high-resolution atmospheric measurement from the troposphere and the mesosphere of Venus. We'll map SO2, H2O, and other trace gases in the atmosphere of Venus with the goal of characterizing volcanic plumes and other sources of gas exchanges in the troposphere and mesosphere of Venus. VenSpec Q is instead a UV spectral imager. Is provided, the instrument lead scientist is Emmanuel Marc from LATMOS. And it's an nadir pointing ultraviolet spectrometer. We'll observe the Venus cloud top during the day side of Venus to map SO2, and support the search for volcanic activity and to understand the sulfur cycle. And thanks to VenSpec U, it would be also possible to map upper clouds and aerosol properties. So here you have an overall of the goals, some of the goals of the Envision mission, and how the different instrument allows to study the different parts of Venus. So starting from radio science, from the core, the mantle properties, crustal thickness, density, lithospheres, properties of Venus. And then you go up in the subsurface layer thanks to SRS measurement, and then a bit up with the VenSAR data, and then you go even higher with the VenSpec HAM. So we are now at the surface, and you can continue the studies in the atmosphere with VenSpec H and VenSpec Q. What is the Envision observation strategy? So Envision will have a science phase of 4 years of science, so 6 cycles, and it will provide in total 200 terabytes of science data return. More than 20% of the surface will be imaged by the S-band of the VenSAR radar at 30-meter resolution. And more than the 2% of these 20% will be imaged at 10-meter resolution. Plus, Envision will provide near global gravity, altimetry, radiometry, near infrared surface mapping, subsurface, and atmospheric mapping with a suite of instruments. What about the instrument science activities? There are already many science activities going on from the instrument teams. I will focus in the next slides a little bit more on the VenSpec suite because that's what I take care of mainly, but be aware that all the instrument teams, science teams are super active. So if you want to know about specific scientific activity of a specific instrument, please just get in touch with the instrument PIs and they will be more than happy to provide you more info. So about VenSpec is performing simulation of observation to check mesospheric SO and SO2 ratio accuracy. For the VenSpec team, in 2023, the VenSpec team of the NASA mission organized a field campaign in Iceland, where DLR also took place, and the data provided are also important for addressing Envision goals. The SRA instrument team is studying radargrams for different stratigraphic targets in order to get ready for SRS data from Venus. Okay, for VenSpec, the science ongoing work can be mainly divided into three main blocks. We have a lot of going on in the laboratory now, so a lot of laboratory work in order to understand and model how the material behave at Venus surface temperature. Because what we will get from VenSpec are data acquired during the night side of Venus. And we have to take into account that the Venus surface is hot, and we need to understand how the materials behave at these temperatures. This is the reason why we have a chamber in our laboratory, in our planetary spectroscopy laboratory at DLR, where we can measure samples at Venus surface temperature. And we are working right now in providing a spectral library for the calibration and interpretation of VenSpec data. In parallel, there is a lot of work going on the Venus atmosphere radiatory transfer model because we want to understand and to model how the emissivity translates into radiance at the top of the atmosphere. And the atmosphere of Venus is quite complicated too, so we need to find the best model, the best method that we can use to retrieve the emissivity from the surface of Venus. We have been also working together with the other instrument teams and with the Envision SW team to provide also a list of high priority science targets for Envision observation. So we are working together with the other instrument teams to identify the most interesting targets for the on the surface of Venus that we absolutely don't want to miss with Envision observation. And in this work, we are defining the areas that we want to cover with which instrument and what are the most important data that we need to address the scientific question that we have. So VenSpec is also a huge consortium. And there is a lot of science work going on. They have been focused on reanalyzing VIRTIS data and the VIRTIS atmospheric datasets in preparation for VenSpec data. They've been performing work on planning, observation, and science retrieval strategy on their data. And of course, a lot of work is going on the maintenance of the International Science Consortium and in joint publication. Because as you can see in this slide, they have partners from Zurich University, from IA in Spain, from Czech Republic, from the Netherlands. So it's really huge consortium. They've been working in performance model simulation of H2O and SO2 plum detection. And they're also investigating polarized radiative transfer Monte Carlo code that will be used for both VenSpec H and VenSpec Q to derive the composition size and altitude of the Venus cloud particles at near infrared wavelengths, and to characterize upper haze optical thickness, spatial and temporal variability. So VenSpec Q, also the main VenSpec Q science ongoing work can be divided into three main blocks. They've been studying the science advantage of obtaining an extended dayside coverage, because VenSpec Q will be focused on observing Venus during the dayside. So currently analysis is going on in seeing how this extended dayside coverage can advance the science output of the instrument. They've been working on Akatsuki retrievals from Akatsuki data in order to retrieve SO2 and UV absorbers from this data. And they've been working also in studying what is the impact of turbulent vertical mixing on chemical and cloud species in the Venus cloud layers. So here you can have an overview of the Envision mission profile. So the launch is currently scheduled for November 2021. It will be the cruise and Venus orbit insertion phase will be followed by an aerobraking phase, followed by an instrument commissioning, and with the start of a science phase middle 2034, and end of the science phase is planned for mid-2038. So 4 years, 6 Venus cycles, and the mission launcher is the Ariane 6-4. What is really important for the Envision mission is also the mission complementarity, because the combining observation from past, current, and future mission will help to confirm and study the evolution of the Venus system. For example, it's really important to compare radar surface changes between Magellan, Veritas, and Envision mission. Also to study the changes in the atmosphere between the different missions to Venus, to assess the Venus atmospheric composition and dynamics, but also to study how the gravity observation changes between the different missions to Venus. And if you would like to have more information on the background information on science activities on the Envision mission, here you have the link here in blue of the ESA Envision website. It's still in preparation, but you can already find there some information. ESA is also supporting several science activities that are relevant for Envision. Two of these activities are, first of all, the development of an open source toolkit for Envision and Veritas SAR imager simulation and change detection. This project is led at the Imperial College London and with the ESA support. And also they are supporting the project of the Venus Climate Database. The ESA support is provided by Cipriani and Guaran. Other activities that ESA is supporting are the providing an integrated cloud physics models, and also to add in this model also a chemistry model for SO2 and H2O. This is part of a project known as Product Science Activities supported by ESA, and it's performed in Denmark. Another work instead performed in Hungary is based on generating GIS-ready high-order data layers of Venus surface information from earlier mission. This will have a free cloud access and also to perform laboratory experiment simulating large-scale circulation of the Venus atmosphere. So this is my last slide. So once again, if you would like to have more information about the Envision mission, you can refer to the website here, linked here. You can also have a look at the Envision Red Book, which is the definition study report from the mission adoption, and is available on the ESA website. And you can also get in touch with the Envision project manager, Anne Pagros, and the Envision project scientist, Anna Gref. Thank you.